Tom Kohler with INO STEM Outreach. Just wanted to show you kind of in an informal way how to do the floating garden and magnet activity, how that works with students. Basically what you have is a little kiddie pool with just a little bit of water in the bottom, enough that these cups will float. These are just condiment cups. That seems to be the best thing that we found for doing this activity, for floating the magnets. So the magnets, the little neodymium magnets, are glued to the bottom of the cup, and they're all glued in the same polarity as per the instructions. So the reason for that is that the cups need to repel each other in the same way electrons would. And so what you do is you have your little cups with the magnets in it and the pool, and it's kind of fun. You can let kids just add a couple magnets at a time. And you'll notice that as you add magnets, they start to behave in kind of peculiar ways. They'll form geometric patterns. And over time, if you add enough, I've put 3 in there, if you add enough of them, they should start to form patterns that match the electron orbitals that you would see, for an atom. So, 1s1, or 1s1, 1s2, 2s1, 1s1, 1s2, 2s1, 2s2, and so forth. And you have s, p, d, and f orbitals. That's maybe a little deeper than you'd want to go with kindergartners, but at any rate, once you get several of them in here, you'll see typically 2 of the magnet cups kind of go to the center, and then you'll see a ring around them. And I won't go too into depth with that, but I just wanted to show you how to do this. It's kind of neat. I'll take a picture when this is all set up and post that. But if you just kind of put the magnets in there, it really doesn't even matter where you put them. And the kids love doing this stuff. Eventually, these magnets will form that geometric pattern that, roughly models the electrons around the nucleus of an atom. Now, we understand it's not a perfect approximation, so if you're a real nerdy scientist or something, we get it. The electrons they're moving, right? It's a cloud of electrons. There's s orbitals, p orbitals, d orbitals, f orbitals, But we're also trying to teach kids, so don't nerd out on them too much. Just let them get in there in the pool, move the magnets around, see that it'll go 2. And it typically goes 2 for your first energy level, and the magnets really do model it. Then it'll go 8 for your next energy level, and with the right number of magnets, it'll go 18. Some variations of this: you can use smaller containers than the pool, but the container needs to match the strength and size of the magnets. So we find that the kiddie pool works just about best. We've used an overturned garbage can lid, and that works too. So I'll go ahead and just throw these all in here, and we'll kind of let them do their thing here for a minute, see what happens. Notice I'm not trying to put them in any particular place. Okay, we'll film up here now for a second. Look at me. There you go. So once again, pretty informal. We've tried some other stuff for little kids. They like to glue their own magnets on. So we'll get some little floaties, and I'll keep these in the kit. And the kids like to glue their own magnets on. And so you might want to set up one pool that's kind of your control. It has the nice cups and all the nice stuff that you've built. And then a pool where kids can just glue magnets on floaties and explore. That's really what science should be. I mean, even today, I noticed that the cups were still moving after I worked on it, and they were finding their positions better. If you zoom the camera up there, I didn't notice it, but that's why. My fan was going. Okay, so a couple other things in the kit. You've got for your nerd out, chemistry teachers that want to get in depth with this, with maybe a high school group. You can show your electron orbital filling chart. You know how to do that, so I don't need to tell you about it. I bring a periodic table. I bring this, which is tells them how many orbitals per subshell in s, p, d, and f orbitals. That's for more advanced students. And then even for the little kids, it's kind of interesting to show them that electrons don't actually go in circles around the nucleus. They form kind of clouds of probability. So there's that to show people. And so a couple other hints. Unless you want to get sore cheeks, get yourself a bike pump to pump up the kiddie pool. What else? Bring the glue gun, glue sticks, right? Bring some paper towels. This is just teacher stuff. I've got some extra foam in there to cut out. The glue you can use to make the cups again.
anyway, let's look back down at our pool and see what's happening. It looks like we've formed an outer ring. I'm not going to count the ring or anything, but we'll go ahead and just put several more in here. And you'll see just over time they'll kind of form geometric patterns that, and it takes a minute, but over time it'll form these geometric patterns that roughly approximate the orbitals of an atom, the electron orbitals of an atom. Anyway, that's it. Good luck with the kids.